All right, hello everyone. I am Alex, Technical Product Manager at Coveo, and I'm joined here today by my colleague Jean-Alexandre, he's Security Engineer at Coveo. So I'm gonna kick this right off, and my colleague will join back later. So goal today, we want to show you and just explain to you how we think deployment speed and security in the deployment can live together. You don't have to compromise on either of those. And we want to take you along, our journey. Instead of listing boring bullet points of different topics, we want to bring you along with the journey and the thought process that we went through. So hopefully you can bring something home, apply it to your own product, to your own deployment, and just make it your own. Really, I'm not here to sell a company. I'm here to talk about and share ideas with you guys today. So going back in time for us, and we are from the on-premise world. So maybe you can relate to that. Maybe you're still in that pattern of delivering your software on-premise. So we went from that world. We're not born in the cloud. So we used to have a fairly limited technology stack, a lot of C++, a lot of .NET. It was all Windows based in one huge monolith that we were delivering through a download link and a downloadable exe. And now so in 2010s, a few years back, we moved to the cloud. So we were not born there. We shifted a lot. So we went from having those few technologies, we really diversified. Now, fun fact, I looked at Stack Overflow, their top 15 of most popular languages. We have them all. So we really went through a limited technology stack to being diversified. A lot of Linux now, but still, and keep that in mind, and probably you can relate to that. We still have some Windows. We still have some on-prem products that we need to deploy. Yes, we are a cloud platform, as most of you are. You shifted to the cloud, and that we did the same. But we still need to think about those on-prem products. So everything we'll show you today, hopefully you can bring those ideas and make it work with the on-prem as well as we did. So just giving you an idea of the scale that we deal with at Coveo. It's not Google, but still it's fairly large. So those are from the last few months. So we processed around 10 billion transactions on our platform. We handle over a billion queries, and over all of that, we were able to have no downtime. So it's a pretty good achievement. But again, I just want to give you those numbers so that maybe you can have an idea of the size of the team. You don't need to be a few thousand developers to be able to put a good deployment and process in place. We were able to do it with that size of a team and still achieve that zero downtime, plus that thousand and plus automatic release in production over the span of 3 months. So we have big goals when we think about our deployment, our product, what we put forward, and I'm pretty sure you have the same ones or at least some variations of it. So scaling, growing, increasing the velocity of developers. That's a big focus for us, and it's really important. And at the same time, of course, we want to minimize production issues. So no downtime, nothing should break in theory. It always happens, but minimize it. And then security needs to stay on top of things. So when we design everything we'll show you today that Jean-Alexandre will share with you, those are the key principles that we kept in mind always. So goal for us today, show you what happened between those two realities. So going from the on-prem back to the cloud, we went through and the work that we did to be able to go through those changes. That was the fairy tale. That's the good look. It all works fine. But in the start, when we were in the cloud, and I'm sure most of you, at least many of you, are still in that pattern. We are in the cloud, but deployments, they look. I like this comparison. It looks like Walmart on a Black Friday. If you have one release every 2 months, everybody's lining up just before the deadline to merge their new feature. It's really merge fast. The last night is a rush for everyone. If you miss it, then you're out of luck. You have to wait for another 2-3 months to bring the feature to your customers, which is really far from ideal. And then still, if you make it to that release, that merge, Hope for the best because there's no way of going back. And if something breaks in production, it's not easy, it's not seamless, it's not quick to fix it up. So that's really the pattern that we had. But on the upside, by that time, we had a great dev culture, and it's something really important for you as well. I'm pretty sure to keep that culture and keep it unaltered. For us, it was really being able to empower anybody to use the right technology for their job. We don't want to limit it to one or two technologies that are getting rusty and having only one stack. We want to empower people to use whatever they want and use the right process and the right CI/CD tools and the right everything for their job based on their needs. We don't want to force one stack to rule them all for everyone. That's really not the goal. So that's something as well that we kept in mind in all of those in all of that deployment. So before I let Jean-Alexandre speak about the technical stuff, just a brief overview. When you think about a deployment, and we'll make sure to cover all of those topics for you. But there are a lot of things to think about. I mean, just quickly, you see that that's just an overview, but there's a lot of different moving pieces when you deploy software. And if you do it all manually, it's really time consuming. It's a tedious job. It's error prone. Everything can go wrong, and you won't want to do it very often. So that's the problem we were aiming at solving, and hopefully we can help you solve the same problem. Solution simple. Automate everything. At least it sounds simple. And this is where I want to bring my colleague on stage so we can really work through everything that we put in place and that hopefully can inspire you.
Yeah, thank you, Alex. So yeah, what we'll be doing now is going deeper into the deployment pipeline in our own solution. So just something I want to emphasize first. This is a whole pipeline that was built by a small team of Coveo employees. So they built the whole thing, and it was then made available to everyone. And we didn't really need to force anyone to embrace that new movement. For all the advantages that came with it, even from a security standpoint or usability standpoint, everyone was glad to use it. So that whole transition went really naturally. So the whole pipeline starts with a package, right? Before doing the whole pipeline thing, we had a motley crew of disconnected elements, right? So when you finish building your code, you have the actual code artifacts. You also have all your infrastructure checklists that you need in order to deploy your code. And then you have the database revisions, and all those kind of things are a little bit everywhere, right? So you'll go and check in your documentation on how to deploy your infrastructure, and then you'll read again on the documentation on how to deploy your revisions. So now what we're doing is we're just doing one whole package with everything included. That package generic, it's really an important thing. At Coveo, we don't believe that one stack is better than another. So to embrace that movement, we need to be adaptable, right? We need to let everyone use any stack they want and still work on the same pipeline. But that package is generic and everything's included. It also has a big reusability, both in the packaging method. So we provide a library for our developers to create those packages. And also that package itself, like it's immutable. This comes with a handful of advantages. So you can just deploy the same, and once it's validated, it's always good. You always know what to expect. And yeah, so we deploy that artifact many times over. It also has an abstracted complexity advantage that comes with it. Developer don't really need to understand everything that goes into the deployment. Just simple configuration file, as you can see on the screen currently, and everything will be taken care of. As you see, this config file is pretty much everything they need to do the whole deployment. At the top, you can see that there's generic product information about what you're about to deploy. And then in the second step, a little bit lower, you'll see the deployment information. So do you deploy in which environment, in which region? How do you manage that whole global environment in a cloud? And then you'll see a little bit under the actual deployment phases. So this is where it can be as simple as you can see on the screen, or it could be a little bit more complicated. You'll see in when we're doing some Kubernetes deployment, you have the advantages of doing more fine-grained configuration. So you can set your deployment style, the speed at which you're trying to move over from a blue-green deployment or everything. And then at the end of the config file, you have our certifier and configuration. This is something I'll come back a bit later on, but keep in mind that those certifier are what really makes our whole pipeline secure. It's all the validation that will come into place before we go into production with a pipeline, with a package. So what's the journey of that package, right? Let's go with a quick overview of everything, as I'll be displaying in the future slides. So here is a whole schematic view of the deployment pipeline. One thing to note here is that the first step is done in an unsecure environment. So it's done in the developer environment on their own laptop. They will work on their code. They will commit it to the VCS. This is all anything that's kind of untrusted. And then the second part of it, the step 2, 3, and 4, will happen in a secure environment, orchestrated to bring the whole deployment up to production. The secure environment has a few advantages. One of them will be that view is allowed for everyone. They can all monitor what's happening. Developers have the right to do some changes, update, launch a new deployment, and approve some steps that they want to keep a manual touch on them. Then the QA and the security team have the capability to approve certain certifier manually in case they would like to override it. And then administrators of the whole pipeline have the global need in case of an emergency if they need to just remove all the locks because we need to bring the production back. This is something that can happen. So for the first step, here it all starts with a merge, right? So developer will merge their code to the VCS and it'll start the continuous integration pipeline. Our OCI pipeline works on Jenkins. That's what we've been using for a long time, even before that whole deployment thing. And the thing is that part was already partly automated, but we did some change on it. It's not the most groundbreaking changes, but this is where we started. So it'll run the linter, it'll run the security check. This is some point where we really like the developer to embrace that Snyk as that capability can report on early security error that you could find while you're debugging or creating your package, so you don't have to wait later on just to know that something's wrong with your package. You can already address it. And then we're going to do the build. Like I said earlier, that build would be a ragtag of different files, right? So what we did instead, and the way we're now building it, is we just added one step in here, which is the packaging step. At that step, we'll just call the packaging library, and it'll just build everything up in a nice, tidy package that then can be sent to the pipeline orchestration. So this is what we'll move here on to the second phase, which is the cloud deployment phase, the cloud provisioning. In this step, we used to do everything manually, right? So an operator had to log in on the Cloud Console and then start clicking and creating resources in the first environment in development. But then he had to do the same thing again in another region and then in another environment, every time hoping not to do any oversights that could cause some error, right? Finally, the operators in there were godlike. They were the one with all the access, and the developer had seldom of them. For compliance's reason, we wanted to keep a separation of duty between both person, and it created friction because the operator didn't always know the whole context of the application, and the devs ended up just remote controlling them to tell them what to do. It wasn't a good point. So what we did instead, we just automated everything. Now the automatic creation of the whole deployment cloud infrastructure is handled by Terraform. So we simply just start the pipeline and tell it to deploy in each environment. Since all of them are similar but not exactly the same, we added some templating capability. So we're using Go template to really inject contextual information about our environment in our Terraform files. This means that the basic file will be the same, and that's the one that's in the package. But when Terraform is actually running it, it'll contextualize everything. This will give us reproducibility, and will also make sure that everything is finely tuned for every environment. Also, there's a parallel capability. If, for example, both of your region are pretty much the same and doesn't depend on one another, you can just deploy both at the same time, saving time. Finally, the developer here have much more control on what kind of infrastructure they're creating, because they can just write them as code. And since they have the capability to approve a manual step in the pipeline, they recontrol the whole step, and the operators are no longer needed. Then once the cloud infrastructure is deployed, move on to the third step, which is the actual rollout of your application. The way we used to do it was much, again, manually. So we had the artifacts that we needed to copy on the actual machines, and then start the services, hoping that you got the sequence between them right, or something would break, right? Also, you had to monitor your update, make sure everything worked, switch your traffic when the time was right, and usually that was done during the night. One problem about the night also is, by going global, what does the night means anymore? So what we decided to do here was, once again, automate everything. By moving to Kubernetes, we managed to do some automatic deployment. Now, we really wanted to make sure that we could still approve the changes and see what would happen when we're doing a Kubernetes deployment. So we developed a compare manifest that lets us see a little bit like the Terraform does, the difference that will happen when you're actually applying your package. You can see here, I have an example of it, which is really inspired from Terraform. It has that same look and feel about what's getting added, what's getting removed. And that's a point that will be shown to the developer. And at that point, you can just say, oh, okay, yes, that's fine. That's exactly what I wanted to happen. Or no, that's not at all what I wanted. And just abort the deployment and do some changes afterward. Also, since we're running in Kubernetes, we have really no downtime. It can just be done in place directly in the cluster by managing the whole traffic of everything. And as a bonus, we have an automatic teardown that will just get rid of the older application that's getting retired. In the last phase, we have the actual compliance phase. And this is, like I said, where all the security comes in. Up to now, we really had convenience and speed that was put into the pipeline. But that last step is really where the magic happened. How it happened before, right? And I'm sure everyone can relate to this. The QA team was responsible of doing manual checks on everything, right? They manually tested that the code was up to snuff. They were manually notified that they needed to do something about the deployment times to check and validate it. And then they gave a manual approval that everyone was waiting for. Same thing with security. Security scans needed to wait for someone to actually run them. And once everything was fine, we gave the go, and the team could continue with their deployment as the operator to do it manually again. To automate this, we needed some structure. So how did we enforce that policy requirements? We have two concepts here. We have the gatekeeper concept, which is it's part of code that will make sure that the package have every required characteristic to go into production. It will look for tags that are applied on the package by the certifiers. And then once everything is fine, it will add its approval, and the pipeline can then approve the package, continue to the next environment. And the certifier, what they are again, code that can validate a specific requirement about the code. And this can be highly different. I'll show a few examples in a minute. But they can go from security requirements to QA requirements to even custom ones that we put in place to make sure we complies with everything that's in our corporate policies. So How does that happen? You'll see here, all of that validation is done automatically. So those are a few examples. So they are the software composition analysis and the license checks are done in the compliance step. We have static code analysis, dynamic code analysis, antivirus run also are all triggered as a QA step to prove the package and make sure that everything is fine. The beauty of this is that they don't need to run sequentially. They can all run parallelly. So we're only slowed down by the slowest one of them, which is, again, a good thing. The results are also automatically stored and uploaded to the cloud. So in case we need to validate that the package or that a certain deployment checked all the bugs, we can just go back and see in the archives if we have all we need. Another thing is that QA are no longer always involved. In fact, they're only notified if something goes wrong. So as much as possible, this will just go on its merry way, validate that everything is fine. And if something goes wrong, the QA will be notified and they can then address the issue. They can go and reject the package if it's for some reason incompliant, or if it's a false positive, or if they have a good reason for whatever happened, they can just send the package back on its way. So once that package is certified, the gatekeeper that you see here will allow the passage to production, and the package can then automatically continue its journey to the other environments. I wanted to highlight here a few of the certifiers that I think are of any informative value. So the SCE and license one, as you probably know, are done by Snyk. So the way we do it is we really use the Snyk CLI to send a new scan on the package we're having. So all the configuration that you saw earlier are exactly for that purpose. So we'll automatically assign it to a Snyk organization, automatically know which project we're scanning, and then we'll even start a monitor so that we're notified if something goes wrong in the future with the package. Like if a new vulnerability happened, well, we'll be right on it to fix it and publish a new package version. Another one that's particularly of particular interest is the package rollout. I spoke about it earlier globally. What that does exactly is make sure that every piece of code we release has specific checks done on them, that they were validated by QA, that the merge were done by having reviews of everyone, by making sure that the reviews were done by someone of the team, someone of the security team, etc. So this is really a custom thing we wanted to do. We can then define in the certifier anything we want, and as soon as something goes wrong, well, we'll have a notification. So this is globally what our pipeline does. Yeah, Alex, do you have something else to add about it?
Yeah, thank you. Yeah, so you saw, you have an idea. It was at the beginning we said one single pipeline, but I think that you probably understood that with the way we did it, and hopefully you can get a few of those tools and bring them back home to just build a deployment for yourself. It's really not one pipeline. It's a set of tools that developers can leverage in the end. And just sharing an example, I think it's a good one. A few weeks back, in our case, we did not have anything in Australia, no server running, no environment, nothing at all in Australia for us. And then in under a week from scratch, we were able to deploy our platform in Australia using that pipeline, all of that automation. And in 1 week, it was up and running and we had customers on it. So that's really the power of when you invest the time to automate everything and just build something, a pipeline that works for you and for your product. This is what you can achieve. And then maybe if you're already at that point, somebody in the audience, in your company, you're already there. Maybe let me share with you a few ideas that we have for the future of that pipeline at Coveo. So first of all, we want to be able to intelligently fix forward. So maybe roll back if something fails based on automatic L check, Maybe it could be to speed up the deployment speed, to be able to bring a fix forward in production faster. Those are the areas we are exploring. And then if you have that, you're able to deploy automatically, globally, uh, just with a few clicks, and you don't need to worry about those. A human will be warned if something goes wrong, but apart from that, the pipeline got you covered. And then if we put really the reflection, the thought process forward, just having a dependency graph between all of your different services, then at that point you can deploy the whole platform, your whole software, just with one click. So the Australia example, we could have pressed play basically, and I'm really simplifying it, but you could press play and the pipeline knows in which order to deploy every pieces, and you're up and running. So with that, thank you for joining. Thank you for your time. Hopefully you were able to take a few pieces of that and you can bring it back home and start building something to deploy your own product. Thank you.